This is one of those examples where the targeted triangles are actually overlapping. Triangle ABK overlaps with triangle CBJ. So the advice is to redraw and unoverlap those overlapping triangles. So let's do that. Let's redraw triangle ABK and triangle CBJ when they're not overlapping each other. Label them and then mark the congruencies that were given in the original picture. So angle A is congruent to angle C. Angle BJC, which is right here, is congruent to angle BKA. So these single marks, it looks like they're congruent angles in this inner triangle, but really this angle is the bottom right angle of this triangle, and this arc is the angle that's in the bottom left of this triangle. So let's go ahead and mark those. Okay, now they're marked. Well, we're trying to prove that these triangles are congruent. And we already have two pairs of angles of the left triangle, ABK, congruent to two pairs of angles for the right triangle, triangle CBJ. For our shortcuts, we know that we have these options for proving triangles are congruent. These are our options, and what we have so far are two angles. So the options with two angles are the ones that we're interested in. All right, so if we can get a side that's not included between these angles, like side BK and BJ, or BA and BC, then we'll use the AAS theorem. Or if we can get a side that's included between the two angles, that is side JC is congruent to side AK, then we could use the ASA congruence theorem. So which one will it be, and how can we prove that we've got a pair of sides between these two triangles? As you try to think about how we're going to prove that we've got a pair of congruent sides, ask yourselves, have you used everything that's been given? And so far we have not used the given information that AJ is congruent to KC. Maybe there's a way we can use this given information to prove that AK is congruent to JC. If we plot point J and K on these sides, we can see that AK is AJ plus JK, and segment JC is JK plus KC. Let's write that out. So side AC is AJ plus JK, and the green triangle's bottom side, JC, is KC plus JK, KC plus JK. So the reason for this is the segment addition postulate. You might recall that means part plus part is equal to whole, part plus part is equal to the whole JC, and part plus part is equal to the whole AK. Oh, that's supposed to say AK right there. There, it's corrected now. Sorry about that. All right, where are we going from there? Remember, we're going to go for the ASA theorem. So we've already got the two pairs of congruent angles. If we can show that side AK is congruent to side JC, then we'll have the pair of congruent sides, and we'll be done. So we're trying to show that the blue is equal to the green. It's time to use the given information that segment AJ is congruent to segment KC. Let's just rewrite this equation for AK, but instead of AJ, we're going to put KC in its place, because AJ is congruent to KC, so the measures are equal. And if their measures are equal, then they can take each other's place. So we're saying, hey, KC, you're going to go in for AJ into this blue equation right here. And now, look at what we have when we compare AK's right side to JC's right side. Those right sides are exactly the same. So now we can say that AK, which is equal to KC plus JK, which is equal to KC plus JK, which is equal to JC. Therefore, AK is equal to JC. And that's a transitive property of equality. We could also say substitution, because we could have said, hey JC, you're equal to KC plus JK. So JC, you're going to go in the game, the blue game, you're going to go sub in for KC plus JK. So instead of KC plus JK, JC takes its place. So we can think of this as the transitive property or the substitution property. And now that these segments have equal measures, that also means that those segments are congruent. And now, between these two triangles that are targeted, we have a pair of congruent angles, sides, and angles. So the triangles are congruent. We've reached our destination by the angle-side-angle congruence theorem. In statement 5, those triangles are congruent by the ASA congruence theorem.